Welcome to Networks Professionals.
Welcome to The Explainer. Today, we're jumping right into a really fascinating dilemma. How do network routers actually decide who to trust when they're given totally conflicting sets of directions? If you spend any time at all thinking about networking, or honestly, even if you just rely on the internet to function smoothly every single day, you know that data rarely travels in a simple straight line. Behind the scenes, routers are constantly chatting with each other, sharing maps of the network, and trying to figure out the absolute best way to send your data from point A to point B. But what happens when the different sources providing those maps just fundamentally disagree? Well, that is exactly what we're going to unpack today. To really wrap our heads around this, let's step away from the tech for just a second. Imagine you're lost and you need driving directions. You've got two options: a local expert who's lived in the neighborhood their entire life, or some random stranger you just passed on the sidewalk. Naturally, you're going to put way more weight on the local expert's advice, right? You implicitly trust their source of information more. Well, it turns out a router faces this exact same human dilemma when it receives multiple paths to the same destination. It's getting bombarded with directions and has to make a split-second decision on whose map to actually follow. It desperately needs a mechanism to weigh the reliability of the source.
So let's bring this into the digital world. Imagine two very common routing protocols hard at work. OSPF is telling the router the best path is to go left, but RIP is absolutely insisting the best path is to go right. Who wins this tug of war? When protocols give conflicting advice like this, the router needs an internal VIP bouncer system to resolve the conflict instantly. And I mean instantly. It needs a cold, hard rulebook so that network traffic doesn't just completely stall out while the router stands there trying to figure out who's right. Enter the rulebook. To solve this, the router evaluates an ultimate trust score called administrative distance, or AD for short. This is simply a numerical value ranging from 0 to 255 that routers use to determine the trustworthiness of a specific routing source. By assigning a strict, unwavering number to every single protocol, the router takes literally all the guesswork out of the equation. It doesn't even have to evaluate the actual path itself yet. It just looks at the ID badge of the protocol delivering the path. Think of this system kind of like a golf score. Lower values are trusted more, meaning an AD of 0 is the absolute holy grail of trust. When a router sees a 0, it basically stops asking questions. It means the source of this routing information is fundamentally undeniable. There is zero doubt in the router's mind that this is the absolute most reliable piece of information it could ever possibly receive. Now, flip that completely to see the other extreme, a score of 255. If 0 is absolute perfection, 255 means the source is totally unknown, completely untrustworthy, and the route is never ever installed in the router's active routing table. It's the equivalent of someone handing you a map drawn in crayon for a continent they've never even visited. The router sees that 255 and essentially chucks those directions straight into the virtual trash can. No way. Let's actually look at the Cisco baseline hierarchy to see how this builds out in practice. Right at the top, representing that perfect trust, is the directly connected interface at 0. The router is physically touching it, so it trusts it implicitly. Manually configured static routes sit right below that at 1. Then, as we move into the dynamic protocols, you'll see solid, reliable ones like EIGRP sitting comfortably at 90, followed by OSPF at 110. The higher the number goes, the less inherent trust there is, tumbling all the way down through RIP at 120, IBGP at 200, and finally bottoming out at that unreachable 255. So going back to our earlier dilemma, if OSPF with its score of 110 says go left and RIP with its score of 120 says go right, OSPF wins hands down. Simply because 110 is a lower score than 120. The bouncer lets OSPF in.
Okay, so that solves the problem of competing protocols perfectly. But what happens when the router receives two competing routes from the exact same protocol? Imagine your router gets two different paths to the exact same destination server, and both of those paths are being provided by OSPF. The router checks the administrative distance, and both paths hand over an identical badge with the number 110 on it. It's a complete dead heat. The whole administrative distance trust fall suddenly isn't enough to make a decision because the source is equally trustworthy in both directions.
To handle this dead heat, the router brings in a second concept, and this one is called the metric. Think of this as a head-to-head showdown between two very distinct tools. Administrative distance dictates the trustworthiness between different routing protocols. But the metric? That dictates the cost within the exact same routing protocol. So AD is checked first to pick the winning protocol, but the metric steps in if you need to pick a specific path from within that winning protocol. Since AD can't tell the difference between two routes from the exact same source, the router relies on these metric costs to finally pick the absolute best path. And what do we really mean by cost? Well, different protocols calculate costs differently. For some, the metric might be based purely on hop count, literally just counting how many other routers the data has to jump through to reach the finish line. Fewer hops means lower cost. For other protocols, the metric might evaluate bandwidth. It'll look at the actual speed and capacity of the connection, maybe even preferring a slightly longer physical path if the cable itself is massively faster. It's really all about finding the cheapest, most efficient route once that initial trust issue is already settled.
To easily remember how all this network traffic is handled and how these two forces interact, just follow this really simple two-step process. Step 1. The router checks the administrative distance to select the VIP protocol. It's always checking the ID at the door first to see who gets priority. Step 2, if, and literally only if, the protocols are tied, meaning they're the same protocol, the router then uses the metric to find the cheapest, most efficient route inside that protocol's specific options. Trust is established first, efficiency is established second.
It honestly is a beautifully elegant system that keeps the entire internet functioning smoothly without needing constant human intervention. Your router, thanks to AD and metrics, knows exactly who to trust at any given millisecond. But it does leave us with one final, pretty crucial thought regarding your network traffic. Your router knows exactly who to trust, but do you know who is managing your routing tables? Think about it. We'll catch you on the next explainer.
Thanks for watching.